السلام عليكم ورحمة الله وبركاته. معكم سامي العلوني from Yambo Industrial College from Electrical and Electronic Engineering Department. My specialization is Electrical Power Engineering Technology, and I'm going to talk about one of the most important subjects in Electrical Power Engineering Technology, which is Control System Analysis. Control System Analysis, it describes the relationship between different systems and how it behaves, what is the characteristics of the system. As an introduction to this subject, I will give Module 1. It's about mathematical foundation, and on Lecture 1 we will discuss about Laplace Transform. Laplace Transform is a very powerful mathematical tool. It transforms ordinary differential equations into algebraic equations. As we know, any physical system can be described by differential equations. So the definition of the Laplace transform is as follows. If we have a function of f of t and we want to transfer it into Laplace transform, simply the Laplace transform transfer functions from the time domain into the frequency complex domain. This can be written in this form of s equal to integral from 0 to infinity f of t multiplied by e minus s t dt, whereas s is equal to sigma plus j omega. It's a complex variable. S is a complex variable because it contains real component and imaginary component. Now we will take this term in the Laplace definition, e minus s t, replace s with its value sigma plus j omega t. This will equal to e minus sigma t dot e minus j omega t. We know by Euler formula that e minus j omega t is equal to cosine omega t plus j sine omega t. So we will substitute this value in here. So e minus st in the Laplace definition will equal to e minus sigma t multiplied by cosine omega t plus j sine omega t. Now we have two terms, that's this term and this term. From here we will know that this is exponential growth or decay. It depends on sigma. So sigma is exponential growth or decay. So here is minus because here is minus, so we will change this sign into minus. For example, if we have a function f of t equal to e minus sigma t, in the graph it will be shown here to start from 1 and decaying exponentially until it reaches to 0, while if there is another function f of t equal to e sigma t, it will exponentially grow until it reaches infinity. Now what about omega? Omega is oscillation frequency. It's the frequency that the system oscillates with. What if sigma equal to 0 in this here? What if this one equal to 0? Sigma is equal to 0 means it's equal to 1. What remains is cosine omega t minus j sine omega t. How this will appear in the graph? It will have a normal frequency.